Hey everybody, in this video we're going to talk about asymptotes on rational functions, and more specifically in this video we're going to talk about the vertical asymptote of rational functions. So an asymptote is essentially, it's a line or a value that the graph approaches but never actually touches. And the way that we find the vertical asymptote is we find what the restricted value is of the function. Well, for this, you can see that here we have x over 2x minus 4. To find the restricted value, we're going to set the denominator equal to 0. So 2x minus 4 equals 0. And then we're going to solve for x. So we'll add 4 on both sides. Gives us 2x equals 4. And then we divide by 2 on both sides to give us x equals 2. And you can see that when we take 2 and replace it with x in our denominator, it gives us a value of 0. And so that means that x cannot equal 2 in this expression. So what information that gives us is that the asymptote is actually the equation of x equals 2. And so what that is showing is that as this graph approaches 2, where the value of x equals 2, it will never actually get there. It can't ever actually touch it. So if we graph this here in Desmos, in order to graph a rational function, if you hit the division bar, it sets up a fraction for you. So I'm just going to put x over 2x minus 4. So that gives you now the graph of this function. And I'm going to zoom out a bit here. And if you look at this, you can see there's actually a horizontal and a vertical asymptote. So it's a value that the graph will approach, but it never actually can get there. And we know that this graph can never have x equal to 2 because that will make the denominator 0 and then have it undefined. So if I put in the equation of the asymptote of x equals 2, we can take a look at this visually. So as you can see, if we zoom out, this graph, as it goes, increases y and decreases y, it gets really, really close to this value of x equals 2, but it never actually touches it. So it doesn't matter how far we zoom down, you know, it looks like these actually overlap, but if we zoom in really, really close, you will see that they don't actually ever touch. And then same goes if we go positive y, we could go up, up, and up, and up. We could go all the way up to, it doesn't even matter. We could go up to 1,000,000. And if we zoom in, you'll see these lines never, ever touch. So that is what essentially an asymptote is. And in order to find it, you just find that restricted value of the function. And then it is the equation of x equals that restricted value. And that is your vertical asymptote.